Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be talking about the segment and midpoint review for the Unit 1 retest here at the end of Quarter 1. So this is an unusual video, probably be taken down after a while, but we're going to start off by talking about the segment addition postulate. We want to remember that the segment addition postulate basically says that a whole is equal to the sum of its parts. So if I look at a picture like this one over here, what I see is that I have a large segment CP, and I would say CP then is equal to CA plus AP. Notice that A is between C and P, and A is between C and P. All right, now I do this on purpose. You don't have to put the A's in the middle, but I do it on purpose because I feel like it draws the C towards the P and helps me see that CP is equal to the sum of these two things. Now the way this problem works is that we have our two givens. CA is 14, AP is 28. So I take that 14 and I replace CA with its value. And then I replace AP with its value. And we get CP equals 14 plus 28, which we see on this line right here. 14 plus 28 is 42. In the next problem, okay, this is the next type. See, PG is given to us as being 23 units long, and IG is 9. So by the segment addition postulate, I know that PG is equal to PI plus IG. Now when we go into substitute, I have a value for PG, so I can replace PG with 23. And I have a value for IG, so I can replace IG with its value, 9. And then when I subtract 9 from both sides, I get 14. So here you see the substitution step. IG is 9, PG is 23, and then 23 minus 9, of course, is 14. Alright, we got 3 practice problems, and I can kind of squeeze them all in here so we can just get this done in one quick swoop. I think it's just 3. Yep, just 3. So here we go. We always start by writing the segment addition postulate. So this is JG equals JO plus OG. Now, JO's value is 7. OG's value is 24. We're looking for JG. 7 plus 24 is 31. Here we have YS equals YE plus ES. YE has a value of 19. ES has a value of 13. So YS is equal to 19 plus 13, which is 32. And for this last one, we have BT equals BO plus OT. BO has a value of 17. BT has a value of 41. We're looking for OT. If I subtract 17 from both sides, I get, 41 minus 17. I got to kind of work this one out. 24. Okay, and so these are the segment addition problems that you're responsible for tomorrow. You need to show this much work for each problem. All right? Okay, it's time to talk about midpoints and bisectors. The only difference between midpoints and bisectors is that one is a line crossing through the middle of a segment and one is a point at the middle of a segment. They both have the same effect, and that's that the created sections are equal and therefore congruent. So let's look at these 2 example problems. In example number 1, we have C as the midpoint, there it is, of AB, which means that the segments on either side are congruent, and we show that with a tick mark like this, so just a vertical mark through the line. That basically means these two segments are equal. So CB would be 6 and AB would be 12, because 6 plus 6 is 12. Of course, this isn't enough. We actually have to show our work, and the way we show our work is like this. We say AC is equal to CB, which is equal to 6. And then we say that AB is equal to AC plus CB, so that's 6 plus 6, which is 12. All right, in the second problem, AB is 34. That's the whole bit. The whole bit's 34. All right, well, we're cutting it in half. So the way we do this one is we pick one side or the other, and we say this. AC is equal to 34 divided by 2, which is 17. And then AC is equal to CB, which is 17. Let's do a couple examples. Okay, here's the 3 regular ones. All right, starting at the top, XQ is 53. So we have a bisector, and the length of one of those sides is 53. So we know the other side is also 53, and the total is 53 plus 53, which is 106. So let's get this written down then. First off, we say XQ is equal to QY. So that's 53. And then we write XY equals XQ plus QY, and that's equal to 53 plus 53, which is 106. All right, so U is the midpoint of GUM. UM is given as 24, so we have a midpoint, so we're equal on both sides. This side is 24, which means this side is 24, and the whole thing is 48. All right, so GU is equal to UM, which is 24. Then GM is equal to GU plus UM. That's 24 plus 24, which is 48 units. Finally, the whole thing is 68. That means that UM is 68 divided by 2, which is 34. Okay, and that means the other side is 34. So here's how it works. GM is equal, actually that's not correct. Let's back it up. UM is equal to GM divided by 2. That's 68 divided by 2, which is 34. Then UM is equal to GU. Oh boy. Sorry, my pen just started acting up on me. GU, which is equal to 34. Oh, it's back now. All right. So there you go. One last problem. This one is an algebra problem, so a little more complex. Here we go. XQ is given, well, first of all, we have a bisector, so these are congruent segments. XQ is given as 6x minus 8. Okay, and QY is given as 2x plus 20. So these are equal. So 6x minus 8 equals 2x plus 20. And this is because of the bisector. So we always have to write down, when we do algebra, we have to write down what we're doing. All right, now we're going to subtract 2x from both sides. I was supposed to change colors. Subtract 2x from both sides. Okay, and that gets us 4x minus 8 equals 20. And then we're going to add 8 to both sides. And that gets us 4x equals 28. And then we divide both sides by 4. And we get x equals 7. But we're not done. We've got x. Now we have to get xq, qy, and xy. Well, xq is equal to 6 times 7 minus 8. That's 42 minus 8, which is 34. And qy is equal to 2 times 7 plus 20. That's 14 plus 20, which is 34. That should be expected. These should be the same. And then xy is equal to xq plus qy, which is 34 plus 34, which is 68. Remember to show all your work, okay? Good luck on the test tomorrow, and we'll see you in class.